record, because I've done that once before. You may. You know what to do, right? There you go. All right, so we're going to be talking about polynomials. You know, my grandma gave me a bird whenever I was 9 years old for my birthday, a cockatiel. Yeah, it was so sweet. I love it. So, you know, years went by. I was about 25, 26 years old, and my son shook his cage. And I only had to feed the bird like once a week because there was a big old bowl of food and water. Well, he shook the cage early in the week, and all the water came out. I didn't know. The bird died. So I starved my bird to death. It was terrible. But not to make light of his death, because that really was sad for me. But do you guys know what you call a starving bird? A polynomial. No? Polynomial? No? Okay.
Oh, polynomial.
All right. Polly want a cracker, polynomial, yeah. No meal.
Oh, no food.
All right, so what is a polynomial? It's not a starving bird. We'll talk about what it is in a minute.
Was that story true, or was that
No, my bird really did die. Yeah, that was very sad. I was looking forward to keeping that bird for my whole life because they live like 50 years. Yeah, he would still be here today. Yeah, well, I'm going from hearsay, not official information from a reliable source, so I could definitely be wrong. But my grandma, she said, oh, they lived like 50 years. I'm like, oh, cool. But I don't know. I haven't looked at it. No, now I'm going to look it up and find it. But anyway, so we'll talk about what the parts of a polynomial are called. We'll talk about different types of polynomials, and finally we'll get to adding and subtracting. So let's begin here with part A. What is a monomial? It's also known as a term. So if you guys ever hear that phrase, like terms, another way you could say that is like monomials, but nobody wants to say that because that's too many syllables. All right, so a monomial is a number. So for instance, 5, that's a monomial. And you guys should add this on your notes. It's a number. Now when it's a number, we call it a constant, by the way, because it doesn't change. Numbers are what they are. They're just numbers. They don't change. But a monomial can also be a variable, like x. That's a monomial. Or it could be those two things multiplied together. So like 5x. That's a monomial. When you multiply them, they become one term, and we call that a monomial. Does anybody else need notes? I've got a few people who came in a little bit later. And it could be more than one. It could be more than one letter. So you could have like a 5 times an x times a y. That's a monomial. We won't be looking at those too much, honestly, but you could. It could be 5 times x, or in other words, 5 times x squared. Okay? So these are all monomials. Now, I just want you guys to know, and once again, hopefully you guys are writing this down as references for yourself. When you do have a variable being multiplied with a number to create a monomial, the number in the front has a name. Does anybody remember it from Algebra 1? Okay, you could call it a constant, but it gets a special name when it's in front of a variable. Coefficient. So, whenever you have a monomial that consists of a number and a variable, or multiple variables, the number in the front is called a coefficient. Okay? So we have the constant, that's a monomial. We have a variable, that's a monomial, or a combination of them. Those are all monomials. All right. I see a few pencils still moving, so I'll wait a little bit and then we'll move on. All right, so I put that there. When a monomial consists of a product of a constant and one or more variables, the constant is called a coefficient. We already said that. Now, this is a funny one. What is the coefficient of this monomial here? There is a coefficient. It's 1. So let's draw that in there. When there's not a number in the front, it does have a coefficient. It's a 1. And what's the exponent or the power on there? It's also 1. So just know that when you see an x, it has a coefficient. It has a power. We just don't write it. Okay. So that's what a monomial is, and it's also known as a term. So when you say when you hear me say combine like terms, that means combine like monomials, and we'll talk about that as well a little bit later. All right. So what is a polynomial? A monomial is a type of polynomial. So you guys know what the word mon means in English? One. So it means one. It means you have one thing. Okay. So, but a polynomial is all the different polynomials that exist. So a monomial is a type of polynomial. So it could be a monomial or the sum or difference of two or more monomials. So for instance, if I take this monomial, 5x squared, and I add it to this monomial, that's a polynomial. That's just another type of polynomial. This one has two terms. You guys know what that's called? It is a polynomial, but there's a special name for this one when there's two. It's not tri. Tri means 3. We'll get to that. Binomial. This is a binomial. Okay? So, but all of those different things put together are called polynomials. Okay, so a monomial is a polynomial, a binomial, trinomial, all polynomials. So when you take two terms and you either add them or subtract them together, then you're creating just a bigger polynomial. That's all you're doing. Okay? So let's talk about the types of polynomials. There's the monomial. We already talked about that, but let's put an example there next to it, 5x squared. I keep using that same one. I'm not very creative, but there you go. And with each of these definitions, make sure you put an example next to it. A binomial is a polynomial with two terms. So, suppose I had 7x cubed minus 9. That's a binomial because I've got two monomials being combined with a subtraction there. A trinomial is a polynomial with three terms. So we have three of them now being added together there. So that's a trinomial.
I love these.
1, 2, 3.
Is that a 5 or 3?
It doesn't matter because it would still work, but I meant it to be a 5. Sorry about my handwriting. All right, now let's talk about this. Can you guys cross the word function off here and put polynomial here? I mean, you could put function there, but I just want to stick to this language for now. A linear polynomial. Let's talk about linear polynomial. Okay, a linear polynomial is a polynomial in which the highest power is 1. So for instance, 5x minus 7. What's the power on the x there? That's a linear polynomial. They call it a linear polynomial because when you graph those, they look like a straight line. So line is linear. Right? Quadratic polynomial. That's a polynomial equation in which the highest power is a 2. So for instance, x squared is a quadratic polynomial. I could add more stuff to it. It doesn't matter. But so long as there's an x squared there, and that's the highest power, that's what we call a quadratic polynomial. And then finally, there's the cubic one. That's the one where the highest power is a 3. So for instance, if I had x cubed minus 8x, that's a cubic polynomial. Okay? So you could have different combinations here. So for instance, you could have a quadratic binomial. That would mean the highest power is 2, but there's two terms. Or you could have a cubic trinomial. That would mean your highest power is a 3, but you have 3 terms. You could combine these and get different types. And that's what I'm going to have you guys do right now. Is I'd like you guys to come up with examples for these 3 things on your own. Just talk amongst yourselves in your groups and figure out some stuff. And we'll see how that comes along. So go ahead and take a minute and give me some examples of each of these things. Just make up your own. And now, guys, just something I wasn't clear about, by the way, is the powers that we talk about, the exponents. Like if it's quadratic, the highest power is 2. The power has to be on a variable, not on a number. I'll be right back. Let me see Jeremiah, and I'll double check. Yes, try to keep it up 10 minutes, okay? There you go, Jeremiah. You get it okay? I like all these. Seems to be a triangle.
Bro, I need that.
Somebody's papers. Oh, we're doing this right. Did someone get student practice?
Yeah. I'm just kidding.
Yeah, but you have to, so for instance, a binomial, what is that?
You did? Yeah. I see all of it.
Okay, so what makes a binomial a binomial? That's an example. What is it that makes a binomial a binomial? Someone has two terms, right? Being added or subtracted. Now, so it has to be a binomial, but also linear. So what makes a linear polynomial? Good. So let's ask, what makes a linear polynomial?
Oh no. I'm just kidding.
The highest power is 1.
Good. So let's take a look. This is highest power on the 1 here. There you go. So this is what we call a linear binomial. It's got 2 terms, 7x and 5. That's 2. And the highest power. No, because a monomial, that's a monomial. A monomial can be just a number, so that is considered a term. Just a number. It doesn't have to have an x to the other term. So we have 2 terms. And one of them has the highest power 1. All right, let's see what you guys have gotten out there. Lily, what did you guys get for number 1 over there? Give me your example. 5x plus 3. Okay, is this a binomial?
Yes.
It's got 2 terms, 1, 2. Is it linear? Yes, because the highest power is 1. So this is a linear binomial. That's a good example there. Does anybody want to check theirs with me before I move on? All right. Azalea, what did your group get for a quadratic trinomial? Okay. Now that is quadratic. And why is it quadratic? Anybody? The highest powers of 2. So that is quadratic. So I agree with that. Now we need it to be a trinomial. So we need some more terms in there. So just make some terms up. Give me a term. Spit one out. 8x. Give me another one. 7. There we go. Now I've got 3 terms. So it's a quadratic because the highest power is a 2, but we have 3 terms, so it's quadratic trinomial. Those are very popular types of polynomials, by the way. Number 3, Crystal, what did your group get? 7x to the third power. Is that cubic? It is cubic because the highest power is a 3. Is it a monomial? Yep. Does it have a coefficient of 7? That's the big number in the front there. That's my coefficient. Lot of cell phone gazers out there right now, guys. You are losing points if you don't pay attention during lectures. You know, I've watched everybody, so make sure you guys are with us, paying attention, and checking your work, okay, participating. Don't be a cell phone gazer. Be a math gazer. All right, let's talk about like terms here now. All right, like terms. Another word for that would be like monomials. So, like terms are two monomials when they have the same variable and the same exponent. So, for instance, if I have this 6x to the 5th, and if I have 4x to the 5th, do they have the same variable? Yeah, they do, right? But do those variables have the same powers? Yes, they do. So these are like terms. So this is an example of a pair of like terms, okay? 6x to the 5th and 4x to the 5th. I see some pencils moving, so I'll wait a little bit and then we'll move on. All right, we good? Speak now or forever hold your peace. So what I'm going to do is I'm just going to give you guys some examples. You can write these down if you want to or not. It's entirely up to you. But I do want your participation. So what I'm going to do is I'm going to ask you guys, are these like terms or not? I'm going to use my cards, okay? So I'm just going to put two terms up on the board. I'm going to ask you, are they like terms? And if you say no, I'm going to ask you why not, okay? So here we go. Alonzo, are these like terms? No, why not? They don't have the same power. All right, very good. So those are not like terms, so that's a no. Let me do another one here. And once again, if you got stumped by one of these and you want to write it down as a note to yourself to help you, go ahead. Let me come up with another one here. Are these like terms? Why not? Very good. Armani, are these like terms? Yeah. They are. Good, because they both have an x and an x squared. Okay. Come up with another one. And if you want me to bring an example back because I'm going too fast, just let me know. This is just me messing with you because you guys have got it now. You guys understand the part that I want you to understand. It seems like from the people I've called on, but for the 3 people I've called on, you guys have got it. But let me ask somebody here. Are these like terms? So let's try Aaliyah. What do you think, Aaliyah?
I think they're not because the exponents are not the same as the
Right. So I'm just making you guys think a little more. They both have an x, right? They both have a y, but this is an x to the 4th. This is an x to the 3rd. This is a y to the 3rd. This is a y to the 4th. So these are not like terms. They have to be the same letter with the same exponent. So it would have to be x to the 4th, x to the 4th, y to the 3rd, y to the 3rd. Okay? All right. Now, why do we care about what qualifies as a like term or not? Well, because that's going to help us with our next topic here, which is adding and subtracting monomials. Okay? So when it comes to adding and subtracting monomials, you can only add or subtract them if they're like terms. Okay? To combine two like terms, all you do is add their coefficients. The variables do not change. So, for instance, if I had 7x to the 4th, you guys should probably write this down. 7x to the 4th plus 9x to the 4th. First of all, are those like terms? Yeah. Now, how do you combine them? All you do is you add their coefficients. Now, what are the coefficients here? 9 and 7, right? all you do is add those. So what's 9 plus 7? 16. But the variable and the exponents do not change. So it's still x to the fourth. It's still x to the fourth, okay? So that's how you add like terms. All right? Now, it could be subtraction, in which case, if I had this, 7x to the fourth minus 9x to the fourth, then that would be negative 2x to the fourth, because 7 take away 9 is negative 2. Okay? But all you do is combine the coefficients. You don't change the variable or the exponents when you combine like terms. So I'll wait a second if you're still writing. And that's going to take us up to our next problem set here. Let me see how time. And we kind of already did this stuff this year also, but I'm just doing it now in the context of our new topic, which is polynomials. We talked about combining like terms earlier this year when we were solving equations. But when we did that, it was really just, they were just x's. There was no x squareds or x cubes or things like that. So. Am I good to erase? All right. So I think we're going to move on to some practice problems now. And you'll have to write these down because I didn't print these. So go ahead and take a moment and copy that down. No, well, we do need to be able to decide if which ones are like terms, but we're going to do more than that. We're actually going to combine the like terms now. Yeah, of course. You don't have to wait for me. It's fine. Like I said, this is all review, but I review it because, you know, it's not like you do this every day. So I probably forgot. All right. I do it every day. I think I'm a weirdo. All right. So let's begin here. Now, guys, bonus point. Raise your hand if you could tell me. What do you call this? Raise your hand if you know what I'm going to call that, Denise. That's a trinomial, right? And so is this one. They're both trinomials. You don't have to draw on you don't have to box them or anything. I'm just showing you. But we have two trinomials that are being what? Added. Okay? So when you're adding, just combine like terms. I'll write that little note on the side, and maybe you want to as well if you didn't know this, but when adding, just combine like terms. But remember, combine like terms, that means something, right? That means you have to find out which ones are like terms, and then when you combine them, you just add or subtract their coefficients, but you don't change the variables. So, here we go. I have a 2x to the fourth. Is there anything like that? The 8x to the fourth. You guys see how those are both x to the fourth powers? So we're going to combine those. And when we combine them, all we do is we add their coefficients. So I've got a positive 2 and a positive 8. When I put those together, what do I get? 10x to the fourth. Good job. Now, I like to do this. I don't always do it, but just to kind of know I'm done with those, I'll cross them off so I don't have to look at them again. Next, this one, bonus point time again. What do we call that one? It's a 7, I know that, but what vocabulary word did I give you guys today for that? Go ahead, Chris. Okay, I'll take that. It's not a coefficient, but I'm going to give you a point anyway because you're close. But we only call it a coefficient if it's with a letter. But there's another word I gave you guys today for that. Constant. It's called a constant. Doesn't matter if you didn't know that. I'm just testing you right now, having fun. So here you go. This is a constant, no variables. Is there anything like that? Just bring it down. Negative 7, just bring it down. It doesn't have any friends. It's like Mr. Bailey. Let's go ahead and check out the... You're supposed to laugh. You're not supposed to be like, oh, that's really sad. It's a joke. I have... Oh, actually, I don't. That is... All right. Next one. Negative 8x cubed. Is there anything like... Let me call on somebody this time. Let me ask Cal. Is there anything like that, Cal? Which one? Notice how they're both negative. So what's a negative 8 when you put it with a negative 3? Negative 11x cubed. Now, if you're a little insecure with your adding, subtracting positives and negatives, please use the calculator. It's fine. Just negative 8 minus 3, and you'll be good to go. All right. And I'm going to cross those off because I'm done with them. All that's left is this 6x squared. He has no friends, so we'll just bring it down like that. Now, just so you guys know on your test, usually they're going to put these things in what they call descending order, which means highest power to lowest power. What's the highest power?
10x.
What's the next highest power?
11.
And the next highest?
6x.
And then?
7.
So you might want to make a little note. Arrange highest power to lowest. Now, you're not wrong. You're not wrong if you don't do this, okay? But I just want you to know on a multiple choice test, it will probably be arranged in that way. So just make it easier to find. Okay? So I'll leave that up there in case you guys are still writing, but that's adding, that's combining like terms.
Why'd you put 10x before 11?
Because we look at the powers. I think you're looking at the coefficients. So the 10 is a coefficient and the 11 is a coefficient, but we look at the powers. The power is 4 and 3, so 4 is bigger than 3, so that comes first. Does that make sense?
Yeah.
So we look at the powers. Did I answer you okay?
Yeah.
Okay. I jumped in on your question a little earlier, just want to make sure I was understanding. All right, so I'm going to bring up number 2. I'll leave some of my writing up here in case you're still writing, but I'm going to bring up number 2 so you guys can start writing down our second one. All right, write down number 2. Write down number 2. We're going to have 3 examples and 3 student practices, so just to give you some vision of spacing and how you'll move those things around. Write down number 2. I want to, you don't have to wait for me if you already know what to do. All right, let me begin here. All right, so before I begin, I want to share a little note with you guys. And if you didn't know this, I would encourage you to write it down. But I have 2 trinomials, but what am I doing with them this time? Subtracting them. There's a minus sign in the middle there. So when subtracting, what we're going to do is we're going to distribute the negative. And what that's going to do is it's just going to change all the signs in that second polynomial. So you can think of it like there's a negative 1 here, and we're just going to multiply it times everything in here. And all it's going to do is change their sign. So the 7x to the 4th becomes negative 7x to the 4th. The negative 8 becomes positive 8. The negative 7 becomes positive 7. After that, I'm going to get rid of the parentheses and just bring everything else down. This polynomial does not change. Only the one that's being subtracted. Okay? So when subtracting, distribute the negative. That changes all the signs in the second polynomial. But the first one will stay the same. Okay? And then after that, guys, it's just the same as the last one. We're just going to combine our like terms. So let's begin. Sophia, is there anything like the 4 that I can combine it with? Good. Both of those are constants. Both of them have no variable, so we'll just put those together. Positive 4 and positive 8 makes 12. All right, let's do another one here. A lot of people have to. But is there anything like the negative 5x to the 3rd? Oh, let me not circle there, though. Let me circle this one. Is there anything like that? No. So I'm just going to bring it down the way it is. There's no other x to the third powers. You cross these off as I go. Okay? Which one do you think it's like? There you go. Good job. All right. No Michelle today. Let's talk to David. David, what do you think about this? Anything like that? No? There is one. Good, because they both have an x to the fourth power. So what's 6 take away 7? -1. Now you don't have to put the 1, but I'll put it there. But if their coefficients have a row 1, they just sometimes don't write it. And, well, all that's left over there is that 7x, so we'll just bring that down. It doesn't get to combine with anything. But once again, we want to put these things in order from biggest power to lowest. So that would be the -x to the fourth. I'll get rid of the 1 this time. Because once again, on your multiple choice test, they're not going to have a 1 there. So -x to the fourth comes first, minus 5x to the third, plus 7x, plus 12. So there's our final answer there. All right, I have one more example. I'm talking a little long today, I'm sorry, but we have one more example. I'm going to let you guys practice, and then we'll be done, okay? So one more example. Go ahead and finish writing that up, or if you want to take a picture, we'll be moving on to our third example. Okay. Last example. Here we go. All right, so why am I including this one? Well, just showing you, it doesn't have to be just 2 polynomials. It could be 3. So we're combining 3 polynomials here, okay? 3 trinomials, to be precise. This one's being, huh? Oh, girl, the party never stops. We're going to go up to like 4, 5, no, we'll stop here. I probably won't go much beyond that, so I just want to expose your mind. But yeah, no, technically it could be a lot of polynomials. But, I mean, there's no sense in being weird about it. We'll stop here. So, let's go ahead and begin here. So now, I'm going to ask Adrian, what do I need to do first? Say it again. Distribute that negative. You guys see that minus sign there? Right here in the middle? We need to distribute that one. And it only goes to this polynomial here. So here, here, and here. That's the only one that's going to get changed because that's the only one that's being subtracted. This guy over here has a plus in front of it, so we're not going to do anything there. Just the guy in the middle. So this one stays the same. Everything here is going to change its sign. So the 6r becomes minus 6r. The negative 3 becomes plus 3. The 5r squared becomes minus 5r squared. And then this one we said is going to stay the same. Does it look overwhelming to write all that? Okay. Okay, you're fine. All right, so is there anything like the 4, Kimaya? What? Good. There's another one. Very good, okay. So all those are the same. So let's put all those together. We have 4, 3, and 3. What does that mean? I agree. All right, cross them off now so I know I'm done with them. Move on to the next one. 8r to the third. Let's talk to, he's not here. Edwin, what's like 8r to the third? Good. So if I put those together, 8 take away 6 is 2. So that's done. Shakir, is there anything like the negative 8r squared? Mm-hmm. So negative 8 and negative 5. That makes negative 13, doesn't it? Okay, good. I felt a little insecure on my adding skills there for a second. All right. And the last one, we have 6r and 8r. Are these like terms? Yeah, so we can put those together. That's going to be 2r. And then we want to put them in order. It's almost completely in order. What's the only guy who's out of place? The 10. So I'm just going to rewrite this in order. And it's a positive 10, right? So I'm going to put plus over there. We don't usually put a plus if there's nothing else there, but I'm going to make it a plus over there. Yeah.
You put plus 2r before 10 because of the r, right?
Yes, so this one has a power of 3. This one has a power of 2. This has a power of 1. And this one doesn't have a variable at all, which means that it has the lowest power because it doesn't even have one. Yeah. Is that a question, Cynthia? No? Okay. All right, guys, so does anybody need to write that still or take a picture or something? Okay. I'll give you guys a little bit, see what you guys get there. Kind of tiny. I'll make it as big as I can. But go ahead and try these 6, and we'll call it a day. I'll come around and check off notes while you guys are doing that, so you don't have to upload today. What is that? My brain just, I have to get used to looking at what happens.
you know, it's just a nice leaf. Huh? Yeah.
You just want to remember me back.
Yeah.
I saw it. I'm sorry. Thank you. I was coming around looking at those groups. Yeah. Yeah. Will, so it's a positive 12, right? But the positive 12, the positive, so typically we put it in front, but since it's our first number, you don't need to put a plus in front of it there. No, that'll be for the next year. Pete is away.
Bro.
So I'll put the answers up so you guys could check them if you want to do that. If you didn't get those or you have questions, just let me know.
Lily, what's your middle name?